So 6.3 worksheet is just a review of things we have already done. Here are some of the rules. If you have forgotten the rules, you might want to take a little screenshot of that. That's a really good kind of summary of all the rules that we have talked about, whether it's holes, vertical asymptotes, horizontal asymptotes, or slant. Okay, so we're going to do some of these together, and then it will be your job to do some of the rest by yourself. I would like to do, let's do number 6 and 7 to start with. So remember, the first step that we want to take for these functions is we want to factor our top and our bottom. Okay, so as we do that, you may notice that the top is factorable. That is x plus 2 and x minus 1. The bottom, that second quadratic piece, is factorable to be x minus 5 and x plus 3. And then for our second piece, let's find the holes. Now remember, the holes are where a factor on the top matches a factor on the bottom. In this particular case, it's where x plus 2 equals 0 or at -2. So for the remainder of the problem, let's use that simplified version to answer the rest of the questions, and we'll deal with the whole in a minute. Now, the next thing I want you to always come up with is the vertical asymptote. The vertical asymptote are the remaining factors in our bottom denominator. Where do those equal 0? And that will be at 5 and at -3. So let's go over to our graph paper. And at 5, let's put on a vertical asymptote. And at -3. So down here below, I'm filling in as I go, but I want you to go in the order that we're doing it. So we have vertical asymptotes at 5 and at -3. So that means that our domain, we are going to be skipping 3 things. The holes and the vertical asymptotes are our discontinuities. Skip them. So we're going to skip -3. We're going to skip -2. We're going to skip 5. Okay. Next, after we've done that much, the next thing I would suggest doing are the zeros in the y-intercept. Now remember, the zeros are just our x-intercept. That is where the remaining factor on the top equals 0. So that would be at 1. So let's put that down. That you could write it as x equals 1, or you can write the point 1, 0. Let's put that on our graph. What is the y-intercept? In our reduced fraction, plug in 0. So we get -1 over -15. So that is the point 0, 1/15. So we're super close to the x-axis. So 0, we're just a touch over to a height of 1/15. Next thing I want you to find is the horizontal asymptotes. Now, our lead term on top was x squared, and our lead term on the bottom, if we multiply all the x's, would be x cubed. Since our bigger power is in the bottom, it is always going to 0. So that means there's no slant asymptote. So we've kind of filled in most everything on the bottom except for the hole. Now, how do we fill in the hole? So that removable discontinuity happened at -2. Plug -2 into our reduced form. So we get -3 in our numerator. And if we plug -2 in the bottom, we get -7. Now, -3 over -7, is a positive number. It's about approximately 0.4. Negative 2, 0.4 is here. So I'm like, something is not right. That is not, okay. There we go. Okay, so we know that this piece heads toward the asymptote. So we just really need to find, does it go down or does it go up? So let's plug in 2. So if we plug in 2, we get 1 on top. We get negative 3 times 5, or negative 15 on the bottom. So it's that at 2, we're at that negative 0.4. And so we're going to go downward. Okay, so that's what that middle section is doing. Let's talk about this right section. Why don't we plug in 6? If you plug in 6, we get about 0.6. So let's go ahead and put that on. That tells me that this piece is locked in this corner. We need to know what's happening over here. So let's plug in negative 4. If we plug in negative 4, we get negative 0.6. So this piece is locked right here in this corner. So that is the graph of number 6. So a little bit weird for sure. So now let's go on to number 7. We're going to do that one together. We're going to follow the exact same order as above. First thing we're going to do is we're going to factor it if possible. The factored top is x plus 4 and x minus 1 over x. There are no factors that match on top and bottom, so there are no holes. Let's talk about the vertical asymptotes. The vertical asymptote occurs at 0. So let's go over to our graph paper and at 0, put on our vertical asymptote. Let's talk about the domain. The only value we have skipped is 0, so that's the only thing we need to skip. Now let's talk about our intercepts and our zeros. Remember, our zeros are just our x-intercepts. The zeros are where our top function is equal to 0. So that is at negative 4. The other place where we have a 0 is at positive 1. Go over to our graph paper. Put those on. What is our y-intercept? Well, if you plug in 0, it is undefined. We never hit the y-axis. So let's put some of this information. So we have no holes. We have a vertical asymptote at 0. We haven't addressed the horizontal asymptote or slant. We have an x-intercept at negative 4, 0, and 1, 0. We have a y-intercept that doesn't exist. Okay. So now it's just our horizontal asymptote or slant. This one has a slant. The reason I know that is because the top power and the bottom power are exactly 1 apart. That top power is higher by 1. So how do we find it? We're going to divide. So we get x plus 3. So that's just the line, y equals x plus 3. So go over to 3. Go up 1 over 1. Make your line. Now, so this little piece is kind of telling us there's probably a piece locked here. This is telling us there's probably a piece locked in there. That's the way slant asymptotes work. They kind of make like this little X pattern. So I am just going to plug in 2 more points and I should have this graph okay. I do have to plug in maybe something over here. Let's plug in -2 and let's plug in 3. If I plug in -2, I get -6 over -2 or 3. So at -2, I'm at 3. So that did securely tell us we're going to follow the asymptote, follow the asymptote. Let's plug in 3. If I plug in 3, I get 14 over 3, which is just a little over 4. It's about 4.7. Actually, it's closer to 5. So at 3, I'm at 1, 2, 3, 4.7. So again, it tells me I'm following both of my slant asymptote and my vertical asymptote. So there is problem number 7. So it is your responsibility to finish the rest. There you go.